So let's start by talking about what radian measure is. Okay? Okay. So let's say we have some angle, right? And then let's take the vertex of the angle, and we're going to make that the center of a circle. Can do better than that. Yeah, it still stinks. And let's say that circle has radius of 1. Oh dear. This arc length is going to represent the radian measure for that angle. Okay, so that arc length would represent the radian measure for the angle that we've drawn. So the unit of length that we're using here is called the radian, and that's kind of what's going on. So we have these two different ways to measure an angle. We have degrees and we have radians. When you have two different ways of measuring the same thing, what are we inherently going to want to have? Well, I mean, they shouldn't be the same answer, because if I measure something in feet and I measure it in inches, I'm going to get two different numbers, right? But what would I want if I have a way to measure in feet and a way to measure in inches?
Conversion.
Yeah, a conversion factor to move back and forth between the two of them. That's exactly right. For feet and inches, what is that conversion factor? 12 inches in 1 foot, right? Everybody's cool? So what we want to do next is we want to create a conversion factor to move between radian measure and degree measure, so we're able to convert back and forth. Cool with that plan? All right, let's show you how we construct that conversion ratio. So let's say we have some circle, and let's say for that circle we have radius 1. Everybody's cool? What we're going to do is we're going to create or inscribe, I should say, a 180 degree angle whose vertex is at the center of the circle. So that green arc that I've just drawn there, that would be the same radian measure as 180 degrees, right? How much of that circle is the green arc? Half of the, what measure of the circle? Circumference. Does anybody remember the formula for the circumference of a circle from your geometry class? It's a long time ago. It starts with a 2. 2 pi r, just r. Pi r squared is area, 2 pi r is circumference. So remember, we said the radius for this circle was 1. So when we plug in the 1 and simplify everything down, 180 degrees is equal to pi radians. That is our conversion factor. So far, so good? Okay? Let's practice using that to convert back and forth between degrees and radians. So the first one says to convert 90 degrees to radians. So the way we're going to set up these conversions is the same way you would have set them up in your chemistry class when you did unit conversions there, like converted between like grams and moles or something like that, right? That process is called dimensional analysis, is where you do a unit conversion. So the way I'm going to set this up is I'm going to set it up as like the product of a series of ratios or fractions. So I start with what I know, and because that is in 90 degrees, I know the unit in the denominator of the next ratio also has to be degrees. So that's where the 180 is going to go. So the pi radians goes on top. Since they have a top and a bottom, the radian or the degrees cancel. And if I multiply that across, I would be left with 90 pi over 180. Now, can we do better than that? Yeah, what can we do with that? Simplify. Great. What does that simplify to? Okay, so the 90 over 180 simplifies to 1/2, so we'd be left with 1 times pi, or just pi, over 2. And depending on the directions, they may ask for your answer in terms of pi or an exact answer, in which case what we circled is great. Or if they ask for an approximation rounded to 2 decimal places, you just type pi divided by 2 into your calculator and press enter. You get like 1.57-ish. Everybody's okay here? Okay. So B says convert. Yes, sir. Of course. 152 degrees to radians. So really the same setup, right? Degrees cancels. We're left with 152 pi over 180. Now, if I try to reduce that fraction, it's a little bit, yes.
You also put the pi radian on the top.
Well, that's where it's at in the fraction, isn't it? Right, when you multiply fractions, you multiply across.
Yeah, like, are you going to put a number there or anything?
A number there. Help me out. You lost me. I'm sorry. Can you just repeat your question? I'm not sure I understood.
Never mind.
No, it's okay. I want you to go ahead.
Are you always gonna put pi radian at this, like, is there never gonna be a number like how it's like 90 on the other side?
Yeah, I mean, yes. There can be a number in front of the pi, or I could type pi over 2 into my calculator and just write 1.57 or something if I rounded it. That's okay. Is that what you're asking?
Yeah.
Okay. This reducing though is a little bit more difficult, right? Can we reduce 152 over 180?
Yeah.
Yeah, you should recognize that you can because they're both even numbers, so certainly they're both divisible by 2, right? 152 divided by 2 is 76, and 180 divided by 2 is 90. Still 2 evens, so let's do it again. So I'd get 76 divided by 2 is 38, 90 divided by 2 is 45. And that's as good as you can do because there's no common factors between 38 and 45. Or if they asked you to give a rounded answer, you could type that in your calculator and you get like 2.65-ish. Colby, is that what you expected here on the next one? Or we're left with an answer in front of the, or number in front of the pi? Or no?
Nothing. It's fine. I got it.
Okay. 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 All right. That was a snort. I heard it. All right. Let's do the next one. This says convert 2 pi over 5 radians to degrees. This is different though, right? Because we're going radians to degrees rather than degrees to radians. So because radians are in the numerator, I know I'm going to need the radians in the denominator. So pi radians in the denominator, and then 180 degrees in the numerator. So the radians cancel. What else do you notice cancels? The pi's cancel also, right? And then 360 divided by 5 is 72. Oh my gosh, Mr. Kulik, how did you do that so quickly? Did I do 360 divided by 5 like long division style in my head that quickly? No. I thought of 360 as 36 times 10. And 10 divided by 5 is easy. That's just 2. And 36 times 2 is 72. Am I going to ask you to do mental math? No. But I'm going to talk about like how you could do it, because I think that those are, like nice foundational mathematics skills to just kind of review as we go. So far, so good? Yes. Okay. Last example here in this set was 1.6 radians to degrees. So this is the same setup as the previous problem, right? So I'll use that same conversion factor because we're going from radians to degrees. So what's that? It's 288 over pi. But have you ever seen a degree, like an angle in degrees that's written as a fraction? Right, and any time in geometry, did you ever see an angle written as a fraction? An angle measure written as a fraction like that? No way, man. Like, do we really gonna do that? No, kind of the convention would be to, let's type this into our calculator and spit out a decimal. 91,673. Would it be wrong if you wrote 288 over pi degrees? No, but like, I wouldn't write it that way. That's bonkers. Whoever read your paper would be like, why? But why? All right. The next thing we're going to talk about, now that we've discussed what radians are and how to move back and forth between degrees and radians, I guess maybe we should write this. So maybe write that. That's our kind of rule of thumb. So if I have an angle in degrees and I want to go to an angle in radians, I multiply by pi over 180. I don't think I need it, but I'll write it down. It's like a nice visual. Some people are visual people. That might be easier to remember. happy to write it. Takes just a second. Maybe it's helpful. Maybe it's not. I don't know. You know, sometimes it's hard to tell. The next thing we're going to talk about is going to be measuring arc length, or how to calculate arc lengths. So we're going to have two arc length formulas. The first one is S equals R theta, where S is arc length, R is the radius in this circle, and theta is the central angle for the circle. And the second formula is also for arc length, is S equals pi r theta over 180, where r and theta are still radius and central angle respectively. The question is, how do I know which one to use? They're both measuring the same thing. If your angle is measured in radians, I should use the first formula. If my angle is measured in degrees, I should use the second formula. Or alternatively, if you wanted, you could just convert all your angles always into one measurement and just pick one formula to use every single time. That's appropriate as well. Right. Let's do some examples of just kind of using these formulas. So in example A, it says solve for S if R is 1.4 meters and theta is 0.98 radians. Since my angle is in radians, the formula I'm going to be using is that first one. So I know that in the problem it gives me that R is 1.4 and theta is 0.98. So I just type that now into my calculator and I get 1.372. But what unit of measure should that be in? The unit for S and the unit for R should be the same. So in this first example A, R was measured in meters. So my answer for S also should be in meters. Okie dokie? Okay. It's nice when it's the same, right? For part B, it says solve for S if R equals 3.8 inches and theta equals 40 degrees. Well, this time our angle's in degrees. So I know I'm going to be using the other arc length formula. I'll just fill in my values. Type this into my calculator and press enter. Getting this into your calculator, though, can be kind of tricky when we get a fraction with a bunch of operations going on like this. Let me show you on your calculator. If you press the alpha button, that's the green one on the left-hand side, and then the y equals button, that opens up the fractions menu. If you pick option 1, that'll give you the horizontal fraction bar on your calculator. That's really nice because what it does is it allows you to type in this problem exactly like it looks on your sheet of paper. And you don't have to monkey around with a bunch of parentheses and worry about that. You just type it exactly the way it looks and press enter. It's a super nice feature because I'm guessing that a lot of us have gone and tried doing problems where we have some complicated thing going on in a fraction, goofed up the parentheses and get the wrong answer because you couldn't get into the calculator the right way. This allows you to just type it in the same way it looks on your sheet of paper, which is super nice. Alpha, that's the green one, and then y equals, that's in the top left corner, right above it, and then just pick option 1 to get that horizontal bar. Tia, was that going to be, I had a feeling. Okay. So I got, what, 2.653, and then again, the unit there should match the unit for the radius, so inches this time. We feel good? Okay. Part C, it says solve for R, ooh, different letter this time, if S is 18 and theta is 2.31 radians. Well, since we're given the radians there, I know I'm going to be using the radian version. If I fill in the values, S is 18, R is our unknown, and 2.13 is our value for theta. I need to solve this equation now for R. How do I solve this for R? Yeah, we'll just divide both sides by 2.13, just doing some like algebra 1 algebra here. So when I do that, I get about 8.451. And because the S was given in centimeters, I know the R also should be in centimeters. Feel okay on these ones? Pretty easy, right? All you got to do is pick the right formula, which you can tell which formula you want just because of whether theta's in radians or degrees, and then you just plug the stuff in and do some algebra 1 algebra to get the answer, right? Not a big deal. Okay, let's take a look at the next one here. So this says, find the perimeter of a sector with a central angle of 1.7 radians, cut from a circle with radius 5 centimeters. All right, big question here. What the heck geometric figure is a sector? What does a sector look like? Yeah, it's a pizza slice. So that's if you imagine a round pizza, not a Detroit-style pizza, the square, not a rectangle, a round pizza. You know, like you slice it a bunch of times through the middle. One of those pizza slices is a sector. So when we see sector, we're just thinking, okay, well, that's a pizza slice. So the straight sides of our pizza slice are going to be radii for the circle. The angle of our pizza slice is the central angle, and the curved part is an arc length. So from our problem, we know the radius is 5. The angle is 1.7. And because that was measured in radians, we know the S is going to be found by using the formula R theta. Now, the second question I have for you now before we move on is, it's asking for the perimeter of this figure. The perimeter is just, in your own words, what is a perimeter? Yeah, the distance around, sure. What would that distance be then? Or how would I find it? What three measurements do I have to add up? R plus R plus S. Pretty straightforward there. Okay, so we'll just plug this stuff in for S. So each of the radii were 5. That was given to us in the problem. S we calculated by doing R times theta. We got 8.5. So 5 plus 5 plus 18.5. 8.5 is 18.5. That's our answer. Everything's in centimeters, so my answer is in centimeters, right? Questions on this one? Okay. The next one is probably the most difficult of the problems in this section. So this problem reads, a car has 18-inch diameter tires on it. If the car is traveling at 15 miles per hour, how many revolutions per second are the tires making? When you read this, or when I read this question, all I'm thinking is this is just a unit conversion problem from miles per hour to revolutions per second. So I'm going to treat this like I would a stoichiometry problem from our chemistry class, where I'm just going to do some unit conversion. Everybody's cool? So I'm going to start with the 15 miles per hour. And now I want to end in revolutions per second. I'm not entirely sure how to go from miles to revolutions right this second, but I definitely know how to go from hours to seconds, right? Do you guys remember how many seconds are in an hour? Okay, well, let's ask a different question then. How many minutes are in an hour? 60.
60 times 60.
And then how many seconds are in a minute? 60. You could have written that as 3,600 seconds in 1 hour also. That would have been fine. If you didn't remember that, though, just do 2 steps. So in doing this, what we've done is we've converted miles per hour to miles per second. Everybody okay with what we're seeing?
Yeah.
So that's where we want to end in the denominator in seconds. What we still need to worry about, though, is taking miles to revolutions. The key to doing that is using that the car wheels or the car tires have 18-inch diameter. Now, again, we read that. What do you notice between, if we look at the units there between miles and inches, what do you notice? It's a really obvious question. They're not the same. What do you think we're going to need to do before we can proceed? Make them the same. So let's convert miles to inches. Does anybody know how many inches are in a mile? I don't either.
700,000.
Do you know how many somethings are in a mile?
800,000.
You should recognize there's 5,280 feet in a mile. I wouldn't expect you to know that offhand, but like after I say it, you're like, oh yeah, it sounds like something somebody told me once.
I was close.
And then how many feet are in an inch? Or how many inches are in a feet? 12. Now, I would expect you to recognize that. So now we're in inches per second. Our final conversion now, we have to figure out how many inches are in a revolution for this tire. So let's think about it this way. Here's the tire. Here's it sitting on the ground. Imagine on that tire is like a piece of tape. And as that tire rolls along the ground, that tape gets stuck to the ground. Everybody's okay?
Okay.
So it's going to roll along the ground, the tape's going to stick until we're back to that same spot touching the ground. How long was that piece of tape then on the ground?
36 inches.
No. Well, how long was the piece of tape on the wheel?
38 inches.
Well, the diameter is 18. How long is that piece of tape? It's 1 circumference.
Oh, we had to get pi involved.
So 1 revolution, and if the tape is 1 circumference when it's on the wheel, it's still 1 circumference when it's on the ground, right?
Yes. Okay.
So my conversion factor there is that 1 revolution is just 1 circumference. And that's the piece that I need. So I remember that circumference is 2 pi r. What's the radius for the wheel?
9.
9, very good. How'd you know that?
Yeah.
Diameter is twice the radius, right? You mathed it, that's fine. And now we're in revolutions per second, right? Let's calculate this. Now this is dying for us to do that fraction command, right? Like look at the nightmare of all the fractions involved here. The calculator with that fraction command I just showed you will make short work of this. So I'll do alpha y equals, and I'll pick option 1. And then I'm going to type the top, but I'm not going to include any of the 1s because if I multiply by 1, it doesn't do anything. So I'll do 15 times 5,280 times 12 on top. And then on bottom, we'll do 60 times 60 times 2 times pi times 9. So I get about 4.669 revolutions per second.
No. Oh, no.
Questions to this point? We okay? Okay. That's going to close section 2.1. Looking at section 2.2. Section 2.2 is just going to be more right triangle trig, basically the stuff we worked on last time, with two little additions. So the first addition, some of the angles might be in radians, whatever, no big deal. Second addition, you know how like sine we defined as opposite over hypotenuse, and cosine was adjacent over hypotenuse, and tangent was opposite over adjacent? How come there's no ratio for like hypotenuse over opposite?
Ooh.
Right? We don't have something for that until right now. So that's the first thing we're going to do, is we're going to define for ourselves a couple, well, three more trig functions. So those three new trig functions are cosecant,
Oh no.
which is abbreviated CSC, secant, which is abbreviated SEC, and cotangent, which is abbreviated COT. It's not going to be a big deal. Just hang on. It looks scary now. It's not going to be a big deal. Let's take a moment and look at the definition between sine and cosecant. What do you notice about those two definitions? So when you say opposite, in mathematics, opposite means one's negative and one's positive.
Are you ready?
Okay, not opposite.
Correct. The word you're looking for is reciprocal, where one is flipped upside down of the other, right? Sine and cosecant are reciprocals. Let's look at cosine and secant. What do you notice?
Those are
Also reciprocals. How about tangent and cotangent? Also reciprocals. So, if I remember SOHCAHTOA, I don't have to memorize these three other definitions if I can just remember which ones are reciprocals of the other, right? So, hopefully it'll be easy for you to remember that tangent and cotangent are reciprocals of each other because they both have the word tangent in them.
Oh wait.
Does that seem obvious?
Yes.
Okay. So I'm left with just trying to remember that sine and cosecant go together, and then cosine and secant go together. The way I remembered it when I was a student is that the cos don't go together. Cosine doesn't go with cosecant.
Never talk again.
So cosine and cosecant don't go together. Rather, so sine has to go with cosecant, and secant has to go with cosine. Cotangent? Okay, let's practice using these.
I got you.
Yes, Lucy. Sure. So, this problem says find the exact values for all 6 trig ratios in the right triangle. The way I would start is by writing down my definitions for the 6. Now, if I look at the triangle that's given to me, and I look at that angle theta labeled on the triangle, 5 is the opposite side, 2 is the adjacent side, and this is the hypotenuse, right? What do you notice that we're missing?
The hypotenuse.
Hypotenuse. How are we going to figure that out?
Pythagorean theorem.
Great. We have a right triangle. We know 2 of the 3 sides. We can use the Pythagorean theorem. So the Pythagorean theorem says a squared plus b squared equals c squared. Which one of those 3 letters is the special one? C. Why is C special? It has to be
The equivalent.
the hypotenuse. The legs can go in either A or B, it doesn't matter, but the hypotenuse must be C. Everybody's okay?
Yes.
So if I plug these in, I say 2 squared plus 5 squared equals C squared. 2 squared is 4. 5 squared is 25. 4 plus 25 is 29. And then we square root both sides to get rid of the squared on the C. So we have that's the square root of 29. Everybody's okay?
Yes, sir.
Okay. What is sine theta going to be? What over what? Number over number. Sine theta. 5 over square root 29. Good. Now if we look at that answer, what's wrong with that answer? Square root in the denominator. Correct. How do we get rid of that?
Square the thing.
Yeah, we multiply the top and bottom by
Yeah, square.
square root 29. Now remember, when I multiply a number times a radical, those don't multiply together, so we just stick them next to each other. What's square root 29 times square root 29?
That's a tough one.
Just square.
You're right.
It's just 29, right?
Not much less.
I think that if it was a piece of paper, Maggie, you would have written down the right thing, but getting it out of your mouth was a challenge there, I think. Tia, of course. All right. Let's do cosecant next. Remember, what is the relationship between sine and cosecant? They're reciprocals.
Yeah.
Now, if I use the reciprocal of this answer, what's the matter? What's going to be wrong with that?
The square root's at the bottom.
Square root's at the bottom. But, this answer is the same thing. It's equivalent, right? If I flip that one, everything is fine. Let's do that. Right? that 5 over square root 29 is still equal to 5 root 29 over 29. Well, let's use the more convenient version then for the flipping. You know what I'm saying? Okay. And that can just be the final answer there. Cosine, what's cosine? What over what? Somebody help me out.
Adjacent over.
I want numbers though
She already has it.
for this problem. That's
Come on.
It's 2 over
Come on.
square root 29.
There we go.
great. And what's wrong with that answer, Gavin?
Square root in the bottom.
Good. So if we rationalize that, what am I going to get? What do I get after I multiply the top and bottom by square root 29?
2 square root 29 over 29.
Awesome. Now, if you can't do that in your head, that's okay. You can write it out. But usually what I like to do is after we do a calculation and it's the exact same thing, we're just going to shortcut some of these things, right? Okay. All right. What's the relationship between secant and cosine? Great. So what am I going to write as my answer here for secant?
29 square root 29 over.
Awesome. So we took, again, we flipped the one before we rationalized, because I don't want to flip the rationalized ones because it makes me another rationalized problem that I have to reduce. It's like a whole mess. Just like do it the easy way, you know? All right. What's tangent going to be?
5 over 2.
Great. And that's perfect just the way it is. What's cotangent going to be then?
5.
Absolutely. Lovely. Wonderful job. Everybody happy? Yeah, Colby.
Did you do all 3 equations like every single time?
Well, it asked in the problem, it asked for all 6.
Oh.
That's why we did them all. For the directions. It depends on what the question asks for. All right. Let's do another. Yes, go ahead. All right. Our next example says, let theta be an acute angle of a right triangle. If sine theta equals 1/3, find the values of the other 5 trig ratios for angle theta. When you read this problem, it sounds different than the previous one, right? It's really the exact same problem. The only difference is they didn't give you the picture. Yeah, sure. So what I want to do first is start by drawing the picture to make it into the previous problem. Everybody's okay with that plan?
Yeah.
Okay. So just emphasize that I'm going to draw the triangle the same way it was drawn in the previous picture. So far, so good. Now, to figure out the side lengths for opposite, adjacent, and hypotenuse, I'm going to use the fact that they gave me that sine of theta is 1/3. Because I know that sine is opposite over hypotenuse. So the opposite is 1, and the hypotenuse is 3. How am I going to figure out what adjacent is? Pythagorean theorem. So a squared plus b squared equals c squared. What goes in for a? 1. What goes in for b? Nothing. Good. What goes in for c? 3. I know that 1 squared is just 1. If I subtract 1 from both sides. 3 squared is 9. 9 minus 1 is 8. If I square root both sides, I get the square root of 8. Can you simplify the square root of 8?
Yeah.
Great. What's it simplify to?
8.
Okay. So you want to break it up into perfect squares, factors with perfect squares in them. So I know 8 is 4 times 2. So the square root of 8 can be the square root of 4 times the square root of 2. And the square root of 4 is just 2. So this is 2 root 2 is the adjacent. So far, so good? Okay. I'm not going to do all 6 of them now because it's now exactly the same problem as before, right? Yeah. I'm just going to do one of the, like one pair. Is everybody cool? All right, so let's do cosine theta. What's cosine theta going to be?
What?
What's cosine theta going to be?
Adjacent over hypotenuse.
Great. And what's the measurement on adjacent?
2 square root 2.
Great. And what's the one on a hypotenuse? And that's good the way it is. What's the relationship between cosine theta and secant theta? They are reciprocals. So we'll just flip those guys. What do you notice though?
You can't have the square root.
Yeah, so how do you fix that?
Multiply by square root.
Great. We don't need to do 2 square root 2. It's fine if you do, but you'll have reducing to do at the end. Let's not though, right? So 3 times root 2 is just 3 root 2. And then 2 square root 2 times square root 2 is just 2 times 2. Right? So this 2 is just that 2. And then these 2 guys make that one. Is everybody okay there? I just want to review a little bit some of those like basic mathematics, like that little algebra 2-ish skills here that it's been a minute since we've probably done a lot. So just kind of review some basic arithmetic that you kind of would practice in algebra 2. Yeah? Okay. And again, I'm skipping the other parts of this problem because it's the same problem as before. So let's say this says find the exact value of sine of pi over 6. First things first, if we're looking for exact values for sine, cosine, tangent, etc., what do we know we're going to have to be using? You know you're going to need the 30, 60, 90 or 45, 45, 90 triangles, right? Remember that now? We talked about this a couple period or lessons ago. Okay, great. Well, let's just look at this trig. Sine of pi over 6, that's not 30 or 60 or 45 or what am I going to do with that? What's pi over 6? It's an angle in radians, right? Well, how do I figure out if that's 30, 60, or 45? Just convert the radians to degrees? What do you think? That'll do, right? Remember we did that just a minute ago? So that's just 30 degrees. So sine of pi over 6 is just the same thing as sine of 30 degrees. Oh, okay. Well, which triangle do I need then? The 30, 60, 90. Okay. So I'll draw my 30, 60, 90 triangle. And I know sine is opposite over hypotenuse. So a over 2a, which just reduces to 1/2. And I'm done. So same idea as what we did last time. We're going to tack on that unit conversion. Oh no! And then it's just like the same thing as we've done before, right? No big deal. All right. What if we ask you to do what if I ask you to do sine of 17? How are the directions asking for the answer? What are the directions telling you to do? Does it tell you how it wants the answer? I mean, the angle's in degrees, but does it tell you how it wants the answer? No. Do you think you need to make it exact? No. So how would you do sine of 17? You just type it into your calculator. What do you need to make sure of before you do that, though? Needs to be in degree mode, yes. So you press the mode button there. Mine's already set in degrees, so I'm good to go. So if I do sine of 17, I get 0.292. Everybody's happy there? But part B says secant of 78. Mr. Kulik, I'm looking at my calculator. I don't see a secant button on there. What the heck do I do? Well, secant was related to which of the other trig functions that we do have on our calculator?
Cosine.
It's related to cosine. How is it related to cosine? It's the reciprocal. So what I'm going to do is I'm going to type in, instead of secant 78, I'm going to do cosine 78, and then I'm going to make the reciprocal. So if you look under the math button, it says x to the negative 1. That's the reciprocal button. So I just type that and press enter. So my answer is about 4.810, rounded to 3 decimal places. What do you guys think? It's okay there?
Yeah.
Good. All right, one more example and I'm through with you for today. Sound good? Okay, let's pull it back together here on the conversation front so we can do this one last example. Talking to you, back corner. Thank you. All right, last example. The directions say solve the triangle. What does that mean when I say solve the triangle? It should be a direction we recognize from geometry. What does solve the triangle asking us to do? What? Find all the sides and all the angles. So one of those should be really easy. It's basically for free. Which one do I get almost for free? The missing angle.
It's 49.
Good. How'd you get 49?
90 plus 41, or 180 minus 90 plus 41.
So we know that there's 180 degrees in a triangle. We know that we've already accounted for the 90 and 41. If I subtract those off, everything that's left over must be that other angle, 49 degrees. Alternatively, you could just do 90 minus 41. The acute angles of a right triangle are complementary, but this is perfectly fine. It's equivalent form. All right. Let's find the hypotenuse next. I'll call that H for hypotenuse. If I use the 41 degree, the 12, and the H, which trig function should I be using? Which trig function should I be using? Ooh, this is too much time.
Cosine.
Cosine, because this is adjacent and this is hypotenuse, right? So cosine 41 equals adjacent over hypotenuse. Now to get that H by itself, I want to start by getting it out of the denominator, so I'll multiply both sides by H. And then we'll just divide both sides by cosine 41. And then it's calculator time, right? Okay, I'm going to leave that button pushing to you guys. If I want to now solve for the other leg, I'll call that L for leg. I'll use the 41, the 12, and then the L. Which trig function do I need to use there? Say it loud and proud. Tangent is correct, thank you. So we'll say tangent 41 is opposite L over adjacent 12. Multiply both sides by 12 to get the L by itself. And then it's calculator time. Once again, I'll leave that button pushing to you. Questions from me from today? I say questions for me, not from me. Okay, fair enough. Your assignment is going to be 1 through 42. Now, you see that and you're like, oh my God, Mr. Kulik, 42 questions. They're not that bad. So, if you look at, if you look at the OneNote, if you look at the problems, convert from degrees to radians. How hard is that? Not hard. Radians to degrees. Not hard. Like, use your calculator, compute the value. Not hard, right? Like, it's pretty easy stuff in here. Like, it's a lot of questions, but like most of them are real quickies. Okay? When is this due?
Sunday.
Well, we don't have school on Monday either, so let's make it Monday midnight. Okay? So, when you do your problems, you can either do them directly in OneNote. If you do that, please do not do the following. Do not copy the page with the problems on it and like write your answers little tiny next to the question. If you want the homework problems on the same page, like make a separate column, like 1, 2, 3, 4, with a place where you can show some work and show how you got your answer rather than cramming it right next to the question on the printout. Can you do that for me? Okay. If you'd rather do your homework on paper, that is fine. Next class, I'll show you how to get something from paper into your homework space on OneNote. Okay? We'll have to use our phones, but shh, I won't tell if you don't. Everybody's okay? Okay. Wednesday, when we meet again, will I assign more homework?
Yeah.
Yes. But when will it be due?
Next
Not this Sunday, but the following, because I want to make sure I have at least one class period before any homework is due, unless we spend like a big chunk of time in class working on it, so that you can ask questions and stuff. Like the Delta Math where you had 40 minutes or something to work on it, I'm fine with that being due without a chance to ask questions because you had a bunch of time to do that. Everybody happy with me? Okay, I'm done.